In this lesson, you will learn about custom chunking architectures, developing custom scripts to handle complex PDF layouts for better vector representation. In RAG, that is Retrieval-Augmented Generation, garbage in, garbage out applies directly to your vector index. If you naively chunk complex PDFs, you lose the semantic structure required for high accuracy retrieval. Let's understand the mental model semantic preservation. The first is the problem. Default chunking, that is fixed character splitting, often cuts tables, headers or bullet points in half, destroying the model's ability to interpret context. The solution is to implement structure-aware chunking. This ensures that cohesive units of information such as a full table or a paragraph beneath a specific header stay together in a single vector. Let's understand the various chunking strategy and compare the chunking strategies. The three chunking strategies are fixed size, recursive character, and layout aware. Let's also understand their uses and the risk as well. For fixed size strategy, it is best used for simple text, logs and blog posts. Risk is high risk of losing context mid-sentence. A recursive character strategy is best for standard documents. The risk is can still fragment nested lists. Layout aware strategy is best for complex PDF, financial reports. Risk is high compute cost, higher accuracy. Let's understand the mechanics of intelligent splitting. First is header anchoring. Use metadata like H1, H2 tags to prepend context to every chunk, ensuring the LLM knows what section it is looking at during retrieval. Next is overlap management. Maintain an overlap that is 10 to 15% to ensure semantic continuity between the chunks. Table extraction. Convert the complex tables into markdown format before chunking to preserve the row column relationship in the vector space. Let's do the practical task using the scenario. The scenario is a legal firm wants to build a chatbot for multi-page contracts. The standard fixed chunking approach is splitting the payment terms section, causing the agent to miss deadlines and amounts. The tasks for you are: use py-mu-pdf or Azure Document Intelligence to extract text from a PDF. Implement a script that detects headings and splits the document based on thematic sections rather than fixed character counts. Add metadata to each chunk that includes the source page and the parent header. So you need to create the new Python function using Visual Studio Code as you have done in the earlier section. So create the Azure function in the Python language and use the source code as shown here. The first step is you have to load the PDF file. The second is to split the PDF file by structural separators while keeping headers together. The next step is execute the custom chunking mechanism, and the last step is add metadata for production tracking. So let's understand some quick reference for the chunking architecture. First is primary tooling, LangChain or text splitters, Azure Document Intelligence for table structure, and py-mu-pdf. Key logic: always prioritize semantic breaks over arbitrary character limits. Metadata best practice: always store the source page and document title in your vector index metadata. This is essential for citations later. Summary is: custom chunking converts raw files into semantic units, which drastically improves retrieval precision by keeping related information together. Pro tip for production is: if your documents contain extensive tables, avoid standard text extractors. Use Azure Document Intelligence, that is layout model, to convert tables to markdown before chunking. This provides the highest possible accuracy for data-heavy RAG workloads.